All right, so once the LT Spice is downloaded and it has been installed, let's start designing some simple circuits. So you see here is the dashboard or screen of the LT Spice after it has been installed. So we just try to click here new schematic or click a file and click new schematic. So here comes a new window. Now we want to put some components over here and some sources. So we see here there is a symbol called component. We can click here, or we have some symbols for the electronic components. For example, resistor, capacitor, inductor, diode, etc. We also have ground, and we also have a label net. We'll see in a moment what this label net is. So what we do here, we can click register R1 and place it on the screen. Then we click register R2 and place it on the screen. And then we on the keyboard we press escape. So we are away from the registers now. So we have these two registers. So if you right click on this component, what you see here is the register properties. So resistance can be given a value. Right now it is R. So if I type 1K, tolerance and power rating can also be given. For a moment, we'll not put that value. Click OK. Similarly, for the register R2, right click on this component. The window will pop up. Resistance R again. We click here and we write the value 1K. Click OK. So these two registers are connected. Now we need a voltage source, for example. So we click the components here, and you see here is a library of all the components. We'll see there are different components, devices, like transistors, like diodes, like MOSFETs, and so on and so forth. So in this, if we want to find a particular component or device, so here is this space where you can directly type the name of that component or device. Or another way is to just scroll these options and find the component or a device. So for example, if I type voltage or VOL, so it takes me to this option. So here is a voltage. In the window up, I see there is a symbol for the voltage source. It could be either DC voltage source, direct current, or AC voltage source, or a pulse. It could be a sine wave. It can be a piecewise linear, that is PWL, exponential voltage source, or SFFM. So if I click voltage, I have a voltage source, and I click OK, I have a voltage source. So I place it on the screen, and I again on the keyboard I will press escape. So I don't have to repeat that component. So now I have this component. So this is a voltage source named V1, and I have to put a value for it. So I right click, again the small window pops up. It is a DC value, DC voltage source. If I want DC voltage source to be used, if I click advanced, like I explained before, I have so many options: pulse, sine, exponential, PWL, that is piecewise linear, and here on the right side I have, if it is a AC voltage source, I will need to put a AC amplitude, AC phase, etc. We'll see that in the subsequent modules. So click none as it was before and write a DC value to it. And you don't need to put small signal analysis properties such as AC amplitude, AC phase, or simply just cancel it. And the original window here, when you right click this voltage source, you have to put a DC value. So if I use 1 volt, and of course it's a practical voltage source, so I can give a value of series resistance. So voltage source will always have some resistance in series with that, but I assume that it is a ideal voltage source. So I just leave this field blank and I click OK. So you see now the 1 volt appears here. Once I have the circuit complete, I will go and click this symbol that is ground. So I click here ground, for example, right here. Again, I press escape, and then I need wires. So I call that, I go here and click this symbol. There are wires. They are used to make the electrical connection. So I click here and I come to the screen. So in order to place the proper view, I will press the space bar on the keyboard. So I see that I have whole components appearing right in the center of a screen. So I see all the components and devices that have been placed on the screen. Other way to do that is click the option of zoom out here or zoom in, right? So I just see that I will press escape and space bar, and then I will do zoom out like this or zoom in like this. So again, this disappears to the right. So I will simply do that, zoom in. But I want it to be at the center. What I'll do here, go here, move, click move, and they select all the portion and then move the whole schematic where you want. So if I decide to place it on the center, it will appear like this. So once that is done, I go to wire, I click here. Now select the node of voltage source and connect it to resistor R1. Again, I hit the space bar. I come back to original position. Now here, another terminal of the voltage source, I connect to the ground. I am making the circuit complete. Here I click connect resistor R1 to R2. Again, resistor R2 is connected to the ground. Once that is done, I hit escape button on the keyboard and I am now seeing all the components and the devices have been connected together. They have their names, voltage source V1, resistor R1, resistor R2, and all of these components and the voltage source, they have their values. For example, R1 and R2 are 1K each. Voltage source V1 is 1 volt. Once that is done, what I can do, I can right click the net. When I do so, I have these options. So highlight net, label net, or delete the net. So I will click highlight option, the net will be highlighted. Again, I hit the escape button on the keyboard. I come back to original position. So what I do and why I do is, if I right click the net, I will click the label net. It means I am able to define or put some name to that wire. So for example, if I say this is node A, and there is an option port type, whether it is an input or output or bidirectional ports. So it is none for me, it is just a net, and I click OK, and this option is available. So I place this name A right on that wire. I again hit the space bar, I again hit the escape button on the keyboard. So this is my net 1 which I can highlight. You see now. Now, again, I hit escape button on the keybar. Now I want to name this wire. So I right click, which wire is this one? So I want to just name it. For example, right click, click label net, and I have this option. I define, I say this is the output of my circuit. So I click the port type output, click OK. So this parameter is incorrect. This is what, because I haven't given it a name. So I give it a name, let's say out, and I select it to be a output. I click OK. So you see now I have this one. So I place it here. Again, I hit the escape button on the keyboard. So I get rid of this. Now I want to connect this to the circuit. So I go to wire, I click out, and I click here. So you see now this wire is now, or this port is now connected to the node of a circuit. Once that is done, my circuit is completed with all these values. So this is basically a simple DC circuit with a voltage source and the series connection of the resistors. So I go to view. because this is a spice. SPICE stands for Special Program with Integrated Circuit Emphasis. We'll explain that in detail. So you see, when I click the view option, I have so many things right over here. I want to create the SPICE netlist. We see in a moment what that SPICE netlist is. It is basically interconnection of all the devices and components in your circuit. So I click here, I see this is a Word file, and it is stored in the directory as indicated. And you see here there is arrangement of the components and the voltage source here. So register R1 first of all. It says it is connected between node A and out. So you see in the schematic, two terminals of the resistor R1 is connected between A and out, and it has a value of 1K. So that is how, if you don't want to create a schematic or draw using this graphical user interface, you can simply have the blank Word file or WordPad, and you start writing this descriptive lines, which is called as spice netlist. So second, R2 is connected between node out and 0. 0 is nothing but a ground. So you see R2, two terminals of it is connected between out and ground. It has a value of 1K. Now V1 is connected between node A and 0. So you see node A and 0, which is ground, and the value of it is 1 volt. There is a dot back and no, it stands for back annotation because we have all these component and devices which have been annotated with their names and values. So that's why this command appears here. And final command is dot end. So it says the end of the spice netlist. So now next step is to simulate this circuit, and whatever the result comes, we have to analyze what it is designed for. So before that, let's have a theoretical analysis of this circuit where we actually see what is the current and what is the voltage in this particular circuit. So for example, if we try to draw this circuit, let's say you have a voltage source of V of 1 volt that is connected to a series combination of the resistor. You see here, this is the ground terminal. You have resistor R1 and resistor R2, both are 1K. Both are 1K. So once, and this is your out terminal, this is label A or node A. This is what we just draw using the LT-SPICE software. So you see the total current that can flow through the circuit is indicated by I, and I will be through Ohm's law. We'll see what is the voltage in the network divided by the total resistance. So it is 1 volt divided by 1K plus 1K, that is 2K, and this is 0.5 milliampere. So 1 volt divided by 2K, 0.5 milliampere is the total current. This we can verify through when we'll do some analysis using the software. Another way, if I want to understand the current flowing through the R1 and current flowing through the RT, they are R2, they are in the series. So the total current which is flowing into the circuit is nothing but the current flowing through R1 and R2. So IR1 is equal to IR2 is equal to I, which is 0.5 milliampere. What about I want to have VR1, that is a voltage drop across R1, so which is nothing but a drop here, which is the voltage drop between node A and node out, right? So that's the voltage across R1. So I will use the simple rule of the voltage division. So it is the voltage division rule says that if I have a two resistors, R1 and then I have a R2, and I have a voltage source connected across it, let's say V equal to 1 volt. Let's draw it in a correct way. So VR1 would be given as the opposite resistor R2 divided by R1 plus R2 into total voltage. So is nothing but 1 divided by 2, 1K divided by 2K multiplied by 1 volt, right? So it is 0.5 volt. So understood that because they are of equal value, both of the resistors, so the total voltage will be divided equally across them. So similarly, VR2 would be 0.5 volt. Okay, so once that is done, we see here, we can come back to our schematic simulation window right here, and we go to click this button simulate. We cannot run yet because we have to define uh, what analysis we want to perform. So let's say edit simulations card command. We click here, we come to this window. So you see there are range of options available, what analysis we want to do: transient, which is time domain, AC analysis, DC sweep, noise, DC transfer, and DC operating point. So currently we are interested in understanding just DC operating point. It is also called as bias point analysis, operating point or bias point analysis. So we'll do that, and the command to do that is .op. So when you are writing a spice netlist, as explained before, in that you include this command, and that analysis will be performed on this netlist. In terms of graphical schematic design, as is shown here, we are now using this window, and DC operating point will be run. So this command will compute the DC operating point of this network. If it has this, if the circuit consists of capacitances, it will treat them as an open circuit, and if circuit consists of inductances, it will treat them as short circuits. So this is how the DC operating point analysis is done. Once that is selected, we click OK, and this command can be placed somewhere here, right? So once that is done, we go to simulate and click run. Another way is there is an option here, right over here, run. We select, and you see now the analysis has been performed, simulation is completed. So here are the result of this operating point analysis. So it's pretty clear. We see what analysis we are seeing here. So V are in the parenthesis A, that says the voltage at node 1, node A. So here is in the schematic, we see the voltage at node A is 1 volt, which is correct, what we have applied. Now another is V out. V out is nothing but the voltage right here. So this is says 0.5 volt. So this is nothing but the voltage across R2. Now IR2, which is 0.005, is the current flowing through R2, is the device current, which is 5 milliampere as we computed. 0.5 milliampere, and IR1 is again 0.5 milliampere as we computed, and the current through both of these resistors is nothing but a current, total current flowing uh, through the circuit. So I of V1, so it says minus 0.005. So why is the minus sign? That needs to be understood. So you see this, the current that is flowing through the uh, current R1 and R2, that is nothing but the current delivered by this voltage source, right? So one is incoming current and one is the outgoing current. So it is, that's why it is showing negative signs. All right, so that's all for this particular analysis. We have seen how we actually can draw the basic circuit, a DC circuit with voltage sources and the current sources, and run a particular analysis with that, which is DC operating point. We before running a simulation, we saw the theoretical response of the circuit, how the circuit currents and the voltages are distributed, and then we perform the simulation using the spice software, LT spice in this case, and we analyze the results.